Welcome back to GCSE Engineering Revision. Today we'll be going through 1.1.2 Polymers. Here is the subject specification for today. Before we start, you might want to take a look at my previous video on materials and their properties, as we'll be using some terms today that have been covered in that video. First, what are polymers? Without getting too much into the chemistry of things, polymers are basically compounds that are made of repeating units. So this could be plastic, certain types of fabric, even DNA is a type of polymer. We'll get into more examples soon. There are two types of polymers: thermoforming polymers and thermosetting polymers. So thermoforming polymers are also known as thermoplastics, and that's where the name plastic comes from. These can be melted after being cured, and they're ideal for recyclable products. Thermosetting polymers, on the other hand, cannot be melted after being cured. Instead, when raised to a high enough temperature, they burn. These are ideal for use cases where high thermal resistance or rigidity is needed. Before we get into the properties of the polymers that you're required to know, one thing to note is it probably won't be too helpful to memorize all of these properties. One thing you could do is remember the use cases for each polymer and work backwards to figure out the polymer's properties. For example, acrylic is widely used for windows. But why? Well, windows are transparent and must be resistant to wear from the weather. This suggests that acrylic has to have the properties of being transparent and being tough or hard. First, we have ABS. I'm not even going to try to pronounce its full name. It is strong and rigid, and it's harder and tougher than polystyrene, but costs twice as much. In terms of use cases, it's used for pipes, toys, and keycaps. As mentioned earlier, PMMA or acrylic can be transparent. It's also tough and hard wearing. So it's used for windows, as mentioned, or as a general glass alternative. It's also used for bathtubs and machine guards. Nylon is hard, durable, ductile, and very smooth. So since it's smooth and has low friction, it's used in gears and bearings. It's also used for ropes and fishing lines, which require high tensile strength. Polycarbonate is strong, tough, and can be transparent, making it perfect for safety goggles. Its heat-resistant quality also makes it a good material to make DVDs. Polystyrene is tough and can either be rigid or foam. This is often seen used in packaging or foam cups and even disposable cutlery. The first of the thermosetting polymers is epoxy. This is strong, stiff, but can be brittle. It's the material they use to make printed circuit boards, or PCBs. It's also used for electrical insulators, adhesives, and as a matrix for composite materials, which will be a trend for thermosetting polymers. Next, we have polyester resin, which similarly is strong, stiff, and brittle, but it has high temperature and chemical and electrical resistance. It's mostly used as a matrix for composite material, namely fiberglass. That's used for boat hulls and car panels. Melamine resin is strong, hard, and stiff. So it's used for coatings, adhesives, laminates on kitchen surfaces, and to make plastic plates. Polyurethane is my favorite of the thermosetting polymers. It's strong, tough, flexible, and temperature resistant. It's often used as foams. If you go to a trampoline park, oftentimes the foam pits are made of polyurethane. And it's also used for home insulation and memory foam mattresses. Finally, we have vulcanized rubber, which is strong, elastic, and wear resistant. Therefore, it's used for tires, shoe soles, and rubber bouncy balls. And that's about it. Thanks for watching, and as usual, slides and resources will be linked in the description.